Hey everybody, today I'm going to be solving problem LeetCode 11, container with most water. You are given an integer array height of length n. There are n vertical lines drawn such as the two endpoints of the ith line are I 0 and I height I. Find two lines that together with the x-axis form a container such that container contains the most water and return the maximum amount of water a container can store. Notice that you cannot slant the container. Okay, that's a good point. This is basically, if you guys are familiar with uh, basic math, you're going to multiply uh, our width and height, here to get our answer. And so the height from here, this is 0 index, 1, 2, 3, 4, 5, 6, 7, 8. And basically we're multiplying 8 to 1, which is 7. So this is 7. And then the height here is 7. So we're doing 7 multiplied by 7. And you get 49. Okay. So saying that, how are we going to be able to do this? Uh, well, we could check every single uh indice, right? We could have like we could check this one, we could check this one, and then we could keep checking. Well, obviously, if we're keeping our left pointer over here, and then we're just keeping like a right pointer, and we're just extending over all the way to here, we know that basically this is going to be the biggest container we can get because water will overflow if we it doesn't matter what height r is right now because l, the lowest one right now, is a 1, and so water can only be contained here. So what is a better way that we can do this instead of checking every single indice, like we starting from here and then we're checking here, then we have to check here, and then we have to check here, right? It's kind of like a lot of work because, like, say we're going from here and then we move L to over here, then we're kind of calculating the same stuff again, right? So if L is here now and then we're going to here, well, we just kind of checked this earlier, but we're going from here, right? We're just subtracting from this previous L that we're at. Then we have to keep checking from here and then to here. It's just a lot of work, right? So what is the better way of doing this? Well, we know that we want to find the maximum area, right? So if we want to find the maximum area, we can go ahead and start at the far ends. And how can we determine how could we determine and get to basically our maximum area? Well, the way how we could do this is we always want to maximize our height between L and R and get the biggest container. So if we're gonna do that, we can basically we can check we can kind of do like a check until L and R are not crossing each other, and so we could kind of do like a while L is less than R. We can kind of have this where we're doing like a sliding window similar to that, and then we're going to uh, compare this one and this one. And remember, we were trying to get the maximum area, right? So comparing these two, which one has the higher height, right? So if R has the higher height, right, then we don't really care about this one no more because this is really small and we want to get the bigger height, right? Right now we have basically our area right here is gonna be 1 by 8 because this is 8, oh 9 actually. So 1 by 9. So 1 by 9, our current max area right now, result is equal to 9, right? Okay, so sorry, this is kind of messy here. So right now it's at 9. So that is our current biggest size right here. All right. So comparing, once when we have calculated our area, then we can go ahead and move our left and right pointer. We decide to move our left and right pointer based on the condition of, well, let's see. So get the area, right? So once when we get our area, like we just showed you earlier, then we're gonna decide move L or R. And the condition for L or R is pick whichever pointer is less, then we're going to move that one. So basically, you can say if L is less, if the height at L, right? If the height at L is less than the height at R, let's just say H for R for height. If it's less than that, then we're going to say L plus equals, right? So we'll say L plus equals 1. Now L will end up moving over here. And then that's basically part of this while loop here. We're gonna move the L and R, and then it's gonna break out the loop. Oh, it's gonna go back to the loop again because L is still less than R. And then we're gonna calculate the area again. So from here it's gonna be, instead of 9, it's gonna be a width of 8, and then 8 you're gonna, to calculate the area, we are going to say um we're gonna say basically R minus L, and then we're multiplying that by the minimum between L between height of L and height of R. So you're saying minimum between H L or H of R. Hopefully this makes sense, right? Because remember, we wouldn't want to pick the highest between the two because water won't be able to be contained in there. So we want to get the lower of the two. Okay. All right. So we calculate the area, and then we could set. Basically, this could be like a current area. Current area is equal to this, and then we're gonna set our result is going to be equal to the max of our current result or of the current area. And then that's how we're going to basically go through. We're gonna just keep comparing. So right here, obviously, our height at R here is less than the height at L here. So we're gonna decrement here, and we know that this is gonna be less. The answer we already know is right here, but we still have to go through all of them anyways. And then we could reach, now since we know this is less, we're going to decrement, hoping to find the higher height. And here we find a higher height here. Now that we find a higher height, we have a condition here where they're the same height. Again, this doesn't matter which one you increment or decrement, just choose one and then calculate the area, and then yeah, move your L and R pointers. Okay, so now that we have the algorithm for doing this, I actually kind of want to show you guys a good practice that you should probably do is learning how to code this in your IDE. So let's go ahead and do that. Because I think it's good practice to be able to learn how to actually make your own coding file and then running the tests in your IDE. Okay, so let's call this container with most water underscore problem 11. That's how I have been naming my problems. And let's go ahead and copy this and paste it. Okay, import this name, typing list. Okay, so let's say our result equals 0. And then let's create a run test. And what I like to do is I like to create the solution object here, and then we're going to take basically the test examples we have here. And then let's go ahead and delete some of the stuff here. Expected equals 49. And I also like to do this as well. I like to say test num equals 1. And then I say object dot max area, pass in our height, and call this our actual, because this is the actual result. And then you say assert uh, actual equals expected, and you're gonna print out test using f string test num failed max area given height expected but returned actual. Okay, and then we could go ahead and also run this test right here. Just oh yeah, actually I forgot to call that function. Run test. Also at the end, print f all tests test pass successfully. It will only print here if we are able to successfully pass all of the asserts. So let's go ahead and run this. This should fail, obviously. We're doing kind of like test-driven development here. So we're going to get the test to fail first, and then we're going to go ahead and run the implementation. Okay. All right, so what is the first thing we're going to do? Is height always going to be a valid list? No. Okay, so we should probably check this first. So let's check if height, if not height, or if height, if length of height equals 0, then we can just return 0 because we're getting an empty list, right? Check for empty. All right, and then so now let's go ahead and set up our left and right pointers. And then we want to get this to the length of height, -1 to get to the end. And then we can have our condition here, while left is less than right. So remember what we're going to do here. We're going to step one is probably just calculate area, current area. So let's go ahead and do that. Current area equals, and that is going to be height left. Oh, sorry. Current area, we're gonna get the length first. So right minus left. Multiply this by our, what was it? We want to get the minimum between height at left and height at right. Minimum of height at left or height at the right. And also I forgot to initialize. Oh wait, I already have initialized the result here. So, and then we're gonna say result equals the max of the current result, which is gonna start off at 0 or current area. Now that we've calculated our current area, then we are going to go ahead and move our L or R pointer. Okay, step 2, move left or right. Okay, so now we're going to compare the two, right? So we're going to say if height at left is less than height of right, then we're going to move our left pointer by 1. Now, if our height at our left is greater than our height of right, oh, and remember the thing I said about picking between one or the other to increment or decrement when we're at a where they're both equal to each other. Like in this case, it doesn't matter which one you choose. So we could either do less than equal up here, or we could do uh greater than equal to here. Um, basically, we also don't even need to write this out. We could just write else because that's the only other option, right? You could be less than, and then this case would be basically this is what it's writing out. Left is greater or equal to height of right. That's what this else case means. Then we'll do right minus equal 1. And then this will calculate again once when we go through this condition here until they both cross, or I mean until they're pretty until left and right are both at the same one, and it should exit this while loop. Okay, and then you can once when that loop is once we're out of that while loop, then we can just go ahead and return our results, and we should be able to get our answer here. So let's go ahead and see if we can run through our examples here. I will also include the other example we have here. And I also like to do this. I like to do plus equal 1. And we're taking this example 2 here. Okay. And then we could let's go ahead and run this. Okay, so it looks like it works. I just want people to maybe consider practicing doing this in your IDE. Of course, it's not necessary, but it has helped me land a job or two before by doing this. And some companies, such as I think Google, uh, you actually don't. You actually take your test and you don't write it in like an actual compiler that like you can run like your code and then it'll spit out whether or not it works or not. So usually they'll just tell you type in like a notepad or something, right? Or you could even impress them by doing kind of what I'm doing, just opening up an IDE and then just saying, hey, can I just code it in this IDE? But anyways, you can see here it works. I like to just get double repetition. I like to code it here in LeetCode, and then I also like to code it in my own IDE, and then I run these tests just like this. I will post. I could post like the format of how I do this, or you could just copy it. And yeah, I just do this, and then I push it to my own GitHub repository, just so I could keep track of like when I'm running out, like doing these practice problems. So the problem I just did was 11 container with most water. All right, guys. Well, hope you enjoyed that. Yeah, that was a fun problem. All right, see ya.